Do you ever question the nature of your reality? Could all that you perceive merely be an illusion, a grand simulation? This is the reality conundrum, the philosophical challenge that has puzzled thinkers for millennia. It's the question of whether the world around us, the world we perceive with our senses, is as it seems, or is there more than meets the eye? Consider this. Every sight, every sound, every sensation you experience is nothing but electrical signals interpreted by your brain. So how can we trust these senses? How can we be certain that what we perceive is the true reality, and not some elaborate illusion? And no, this isn't the plot of a science fiction movie. This is a genuine scientific and philosophical debate. It's a hypothesis that has sparked countless debates among scientists and philosophers alike. This isn't just a philosophical quandary, but a hypothesis that has sparked countless debates among scientists and philosophers alike. Enter the simulation hypothesis, a proposition that our reality might just be an advanced digital simulation. Now let's dig a little deeper, shall we? At the core of this hypothesis is the thought-provoking paper published by philosopher Nick Bostrom in 2003. It sparked a serious debate, suggesting that we're more likely to be living in a simulation than not. Imagine, if you will, a post-human civilization, technologically advanced to the point where they can create a simulation so intricate, so detailed, it's indistinguishable from what we perceive as reality. This brings us to the brain in a vat thought experiment. It's a classic philosophical conundrum. If your brain were in a vat, hooked up to a computer that perfectly simulated reality, could you know for sure that your perceived reality is, in fact, real? Could you tell the difference between the simulated and the authentic? And it's not just philosophers who are intrigued. Influential figures like Elon Musk and Peter Thiel have expressed interest in the simulation hypothesis. Musk even went as far as to say that there's a 1 in billions chance that we're living in base reality, suggesting that the odds are in the favor of us living in a simulation. But as mind-bending as it is, the simulation hypothesis is just that, a hypothesis. It's an unproven concept, a speculative leap into the realms of the unknown. While it's a fascinating idea and one that has prompted much philosophical debate, it's still difficult to prove scientifically. The challenge lies in the sheer scale and complexity of such a simulation. How would we even begin to look for signs of a simulated reality? And if we did find such signs, could they be explained by other means? While intriguing, the simulation hypothesis remains a theory, one that is as captivating as it is difficult to prove. But what if certain scientific observations could lend some credence to this hypothesis? Let's dive into the world of quantum mechanics and the fine-tuning of physical constants. These are two areas of science that have left researchers scratching their heads, and some argue they could potentially support the simulation hypothesis. Quantum mechanics, the branch of physics dealing with the smallest particles of the universe, is chock full of phenomena that seem to defy our everyday understanding of reality. Quantum superposition, for instance, describes how a particle can exist in multiple states at once. It's as if you could be both sitting and standing at the same time. Strange, isn't it? But in the quantum realm, this is not only possible, it's the norm. Then there's the fine-tuning of physical constants. These are the numbers that govern the behavior of the universe, such as the strength of gravity or the speed of light. They are set with an incredible precision that, if altered even slightly, could result in a universe where life as we know it would be impossible. Some argue this fine-tuning is evidence of a designer, or in this case, a simulator, carefully calibrating the universe for our existence. However, it's important to note that alternative explanations do exist. For quantum mechanics, the Copenhagen interpretation suggests that particles don't have definite properties until they're measured. And for fine-tuning, the multiverse theory proposes an infinite number of universes, each with different physical constants, and we just happen to live in one that's right for us. Yet, despite these alternative theories, the simulation hypothesis continues to intrigue. It's the idea that our reality could be a meticulously crafted digital construct that keeps us pondering. And perhaps one of the most intriguing of these observations is the double-slit electron experiment. This experiment, a cornerstone of quantum mechanics, challenges our understanding of reality. Let's imagine a scenario. You're in a room with a wall that has 2 slits in it. You have a gun, but instead of bullets it fires electrons. You fire these electrons towards the wall and something peculiar happens. When you are not observing the electrons, they behave as though they are waves. They pass through both slits simultaneously, creating an interference pattern on the wall behind it. This is much like the way ripples interact when you drop two pebbles into a pond. Now, let's change the game a bit. You start to observe the electrons as they are being fired. Suddenly they no longer behave like waves. Instead they act like particles, passing through one slit or the other but not both. The interference pattern disappears, replaced by two bands of impact points corresponding to the two slits. This is the crux of the double-slit electron experiment. It's as if the electrons know they're being watched and change their behavior accordingly. It's a bit like a mischievous child who behaves differently when they know an adult is watching. This phenomenon is known as wave-particle duality. It's one of the most mind-bending aspects of quantum mechanics, and it's been tested and confirmed countless times. It's a real thing, even though it defies our everyday understanding of how the world works. What's even more intriguing is that this isn't just limited to electrons, it applies to all quantum particles. They all seem to behave like waves when unobserved, and like particles when observed. This strange behavior has led some to suggest that we might indeed be living in a simulation. So, how does this experiment tie into the simulation hypothesis, you might ask? The double-slit electron experiment, at its core, showcases the strange and unexplained behavior of quantum particles. When not observed, electrons appear to exist in multiple states at once, a phenomenon known as superposition. But when we observe or measure them, they snap into a single state. It's as if the act of observation itself determines the electron's state. This behavior, while confounding in a traditional physical framework, could potentially be explained within the context of a simulated reality. Imagine, if you will, an advanced civilization creating a simulation of our universe. To conserve computational resources, they might program their simulation to only render certain details when necessary, much like how a video game only renders the parts of a scene visible to the player. In this scenario, quantum superposition could be viewed as a sort of computational efficiency. The system maintains all possible states of a particle until the moment it needs to render a specific outcome due to observation. This interpretation suggests that the observed behavior of electrons in the double-slit experiment could be a programmed response, a part of the operating system of our simulated reality. If we accept this line of thought, then every act of observation might be a direct interaction with the underlying code of our universe. It's a wild concept, to be sure, but it's one that the simulation hypothesis allows for and even encourages us to explore. If our reality is indeed a simulation, then perhaps the mysteries of quantum mechanics are not so much fundamental truths of nature, but rather hints at the underlying structure of the simulation itself. The implications are mind-boggling, aren't they? So, are we living in a computer simulation? This question has been the core of our discussion today. We've journeyed through the enigma of reality, dived deep into the simulation hypothesis and its profound implications. This theory, sparked by philosopher Nick Bostrom, gives rise to the idea that our reality might just be a sophisticated digital playground crafted by a post-human civilization. Our exploration took us into the realm of quantum mechanics, where we dissected the double-slit electron experiment. This experiment opened doors to an interpretation that aligns eerily with the simulation hypothesis, suggesting that reality may not be as straightforward as we perceive it to be. However, the simulation hypothesis remains a topic of debate, its veracity hinging on scientific observations that are open to alternative explanations. The challenges in proving or disproving this hypothesis are immense, but it's this very challenge that fuels our curiosity. While the answer remains elusive, the question itself continues to captivate us, pushing us to explore the boundaries of our understanding of reality.